Hey everybody, thank you for clicking on this link. This is a recording of an Ask Me Anything with the creator of Keras himself, software engineer at Google, Francois Chollet. This is a part of, sorry for the table shake. This is a part of our reading group at Weights and Biases, where we will be going over the book Deep Learning with Python, second edition, which also has been written by Francois. It's such an honor to kick off the series with an Ask Me Anything. We did this on a Saturday, and over the next few weeks, we'll be going over the chapters in sequential order. With this recording, you can find the sign up link in the description if you want to join the future sessions. We're still in the early stages, and I invite all of you to join if you're interested in learning Keras. And I look forward to seeing you all in this meetup series. Here's an intervention by editor Sayyam. I wanted to mention, in an effort to invite everyone to spend more time learning Keras, we're kicking off 27 days of Keras. The only requirement to join is spend 15 minutes to 24 hours every day learning Keras. Write about it, share a notebook, share a blog post, use the hashtag 27 days of Keras and tag either me or Weights and Biases on Twitter. And every single week, we'll be sending out swag to people. This is to encourage everyone to, first of all, spend time learning Keras, and second of all, also share their work. I'm quite biased as someone who creates content, but I think there's a lot of learning that goes on there, and it's also useful for your career. And if you'd like to learn Keras, I hope this excites you. Hey everybody, thank you for joining us on a Saturday. I have been asking stupid questions to really smart people for a long time, but it's been a long while since I've gotten these shakes, because today I get to interview on your behalf Francois Chollet. We'll be reading his incredible book's second version, Deep Learning with Python, which is by Manning Publication. And this is an AMA session that Francois kindly agreed to join to answer any of your questions around Keras, deep learning, or otherwise. Francois, thank you so much again for joining us today.
Yeah, thank you for the very nice intro, and yeah, it's my pleasure to be here with you today, early morning, and to answer any question you might have. And if you're reading the book, please enjoy the book.
I wish I would have been able to flip the pages, but I've littered all over the pages with my notes. So I won't do that, because I think that makes the book look a little bit bad. To the audience, please keep asking any questions, and I'll be picking them from the portal. The Ask Me Anything will go on for 20 minutes, and past that, I'll start going through the chapters in sequential order. Francois, I want to start by asking a stupid question. How does someone at your level continue learning today? What techniques do you follow today? How do you go about learning any new topic?
Learning any new topic. Okay, so first of all, I'm not sure there's really like a universal technique for learning any topic. Every topic kind of calls for a different strategy. Like if you're learning a new language, that's not the same if you're learning music production. It's not the same if you're learning history or neuropsychology or something. So I guess the first thing to do is identify what's the best learning technique for that specific topic is going to be. Like for instance, what are the best language learning techniques or something. So now if you're talking about academic topics, like if you're talking about deep learning, for instance, or physics or something, I really like the Feynman method. And you probably already know about it, but the gist of it is trying to learn a topic by pretending to explain it to a child. So first you should figure out what's the highest quality resource for learning, like a specific textbook or maybe a specific set of online lectures and so on. And then you go through the materials, and once you've done that for each chapter, for each part, you try to summarize to yourself what you just learned. You try to organize and simplify the mental model that you just built of what you just learned. And you can do that. That's the Feynman technique. You can do that by pretending that you're teaching the topic to a friend or to a child, because you want to be able to explain in very simple terms. You want to break it down to a level where you're really sure that you actually know what you're talking about, that you're not fooling yourself into thinking you understand the words. And that process of introspection of your mental model, which is very fresh in your mind, that will lead you to better organize things in your mind. It will also lead you to identify flaws or like inconsistencies, things you don't really understand, things you're not able to explain, to articulate. And then you can go back to the materials with that in mind. So don't just like read up on something, like read a book chapter and assume that, yeah, like that was easy. I just understood everything. Go back to your mental model, right? And try to articulate, what did I just learn? What is this thing about? So always try to probe your understanding, inspect that mental model, because it's by inspecting it that you're going to be able to find flaws in it and improve it. And a related technique is mind mapping. I don't know if you know about mind mapping, but it's very similar, right? It's about trying to write down what your current mental model of something is in a very visual fashion by just connecting concepts and doodling and so on. So you can see it's almost the same thing as trying to explain that topic, but more visually. And the visual aspect is actually interesting because I think information in your mind is kind of organized as a graph. So making that graph explicit actually helps. Basically, by drawing something on paper, it's almost as if you're editing your literal mental model in your brain. So I think it's also a very powerful technique.
That's such a powerful answer, active recall and explaining to someone. I know you're very vocal on Twitter about the Keras community's contribution about blog posts and everything. Those to the audience as a suggestion, writing blog posts is also a great way of following this.
Absolutely.
If I may, for someone who's studying your book, what would be your suggested homework? Who would you call a successful student? What can we do to become successful students?
All right. So I guess the main thing in mind is, like sure, you should read the book. That's like the first step, but that's not nearly enough. Like the book gives you the knowledge, like the mental models, and it gives you a starting point for your intuition, but it does not give you the practical experience and the practical intuition that you're going to need. And to do that, you need hands-on experience. So make it hands-on, right? Like instead of just finding the code examples I give you, try to modify things. Try to come up with your own ideas. Like, hey, maybe I should run this image classification model on different data set with different properties, or hey, maybe I can use different kind of layer. Maybe I can use different kind of regularization and so on. And then you just see what happens. And by doing this, repeatedly, like coming up with ideas like what if, and trying to implement it and seeing what happens. That's how you actually build your intuition. It's also how you build kind of your understanding of where things are in the API, how to code up things, and so on. And once you're like towards the end of the book, you've read through everything, you feel like you know everything, then you should start practicing on some end-to-end problems. And that's where the Kaggle competition website, right, the machine learning competition website, is a great resource because it's basically a great database of different problems and data sets covering all kinds of practical topics. So that's something you can work on. Like the follow-up homework would be try doing some Kaggle competitions. Maybe also try teaming up with someone on Kaggle and learning from that person and so on.
I'm quite biased. I'm also drinking my chai from my Kaggle mug today, but I think
Awesome.
It's one of the most powerful communities. This is so I spoke about the Keras ecosystem where people contribute incredible open source examples. This question is by Ankit, and I think many of us suffer imposter syndrome. We're too scared to contribute. Any tips on how we can contribute or go past the imposter syndrome to contribute to the open source ecosystem?
Right. So I don't think it's that difficult to contribute to Keras. Like if you have the knowledge of how to use Keras, then you're probably able to also contribute to Keras. And there are different levels at which you can contribute. And my recommendation is basically you should scratch your own itch. Like if there's something about the Keras API, for instance, that's been bothering you, maybe like a useless warning somewhere or a bug or a missing feature, then that's where you should start. And if you don't know what you can do about it, then you can just start by describing what you want. You can just open an issue, file a bug report, and so on, and make it, make it actionable, make it high quality. So that's like the first step. And then the second step is you can basically start diving into the code base and start figuring out, what would it take to actually make a change, and we can actually guide you, right, if you ask us questions. And if there's not like any specific feature that you're thinking about, if there's not any specific bug that you run into, the other thing you can do is just code example contributions, like, or improving the docs. Like, hey, you were ringing up on some symbol and you found like there's some short explanation paragraph, there's no code example, for instance, or like you didn't really understand what it was saying, so you want to rephrase it, something like this. This is actually super helpful because any sort of change you're making, like to the docs or code examples or the code base itself, that's going to be, reread, reused by like thousands of people. So you're actually making a big impact with small changes ultimately. So anything that you feel would have been useful to you, that's actually going to be useful to thousands of people after you. And that's why that should be your motivation to actually try to dive in and make change.
I know you spend a lot of time personally as well mentoring the incoming contributions. Do you have any favorite resources that the community has contributed to the Keras.io website?
Yeah, I mean, I would say, in the Keras ecosystem, I mean, it's very much a community project. So lots of things have been contributed by the community. In terms of the Keras.io examples, I mean, they're a fantastic resource. Like, we've got something like 130 different examples, more than that actually now. I think it's like 132 or something, and they've almost all been community contributed. Like, I've made very few of them. I've made like the first like maybe 20 or so, or 15. And yeah, I mean, this is like one of the best resources to learn deep learning in practice. Like, it's super high quality content, and it's like it's made by you, right? Yeah, so that's been an incredible effort, and it's only been like less than 2 years. So hopefully, in another 2 years, we're gonna have like 500.
I'm sure the community really loves Keras, and these are, as you mentioned, quite high quality. Each of the individual examples, the code, the prose. There's a question by Jackie Boscher. Do you plan to include transformers into Keras in the near future?
Right, great question. Yes, so there are several things we want to build in 2022, and one big thing is we want to work on domain-specific extension packages of the Keras API. So one for computer vision and one for NLP. So Keras CV and Keras NLP. And in the Keras NLP part, there's going to be transformers. So specifically, there's going to be like high-level building blocks, like Keras-level building blocks that you can use to quickly assemble any sort of like modern transformer architecture that you want. And we also want to kind of use that as a basis to kind of build an extended version of Keras applications. Like, currently, Keras applications, it's like these pre-trained image classification models for ImageNet. And that's like useful, but that's very narrow, right? We could actually cover so many more tasks, like image segmentation and object detection, and also NLP tasks like summarization, text generation, and so on, question answering. And we should actually we should have a much bigger set of applications covering many more tasks and with pre-trained weights as
well. There's a follow-up question along those lines. I know you like to think in generally about broader topics as well. In your opinion, do you see machine learning converging to just transformers in the future?
No, I think that's not super likely. I think so. Transformers are actually a very interesting and versatile. But I think so. One trend that's definitely going to carry on is that we're going to see the application of transformer building blocks in many more domains and to many more problems. I don't think we're going to converge to one universal architecture that kind of runs against what we know about machine learning, where for each domain, there's actually a specific set of kind of like prior knowledge that you already have about the domain that the model would benefit from. So if you know about the structure of the visual space, you can leverage that to build better architecture. And in fact, today, some of the best computer vision architectures, they're not pure like transformers from the NLP world, right? They've been combined with convolution. They've been very heavily modified. So I think that's kind of like the trend you're going to see. We're going to put multi-head attention in more and more architectures, right? We're going to reuse what we've learned from transformers to improve all these architectures, but we are not going to converge onto basically the original transformer formulation from NLP.
Makes sense. I have an unrelated question to continue. I'm sure you might have thoughts around JAX. So any things you could say about the JAX ecosystem and any interesting ideas you like there that we might see being migrated into Keras in the future?
Right. So I mean, that's a deep question. Like I think JAX is very nice, and it's been adopted by the research community as well. And personally, I like it. I think I like the fact that it's very simple and minimalistic, and it's a very simple, functional, stateless mental model that's very easy to make sense of. And I do kind of want to try to see what we can do at the intersection of Keras and JAX, right? And that's actually an area where I would appreciate, community feedback about what folks want to see. Like very often I will hear something like, hey, why don't we build a JAX backend for Keras? But of course, the reality is not quite so simple, right? So there are roughly three things we could be doing about JAX. So one is, Keras used to have a multi-backend architecture, right? Where basically everything in the Keras code base would eventually boil down to a set of calls to this backend API, which was a wrapper around either Theano or TensorFlow or MXNet or CNTK and so on. And that had, some interesting properties that also had some downsides. And one path we could take is try to refactor Keras to, adopt a multi-backend architecture again, and do so in a backwards compatible way, so that current users of the TensorFlow backend would end up with still the same code base. And this would actually be quite difficult, not just in terms of being a lot of work, but in terms that, most things we do in Keras today would not be supported in JAX, like pre-processing layers, for instance, where we're using basically hash tables or where we have like text input. So that doesn't run using XLA, right? Or distribution strategies. We would have to have an entirely different API for distribution. So we could do something, but it would not really be feature complete because we specialized in the features of TensorFlow to such a heavy extent. And of course, all the related, like what makes the value of Keras models is not just the model itself and the Keras API itself, it's all the surrounding ecosystem, right? Like, hey, if you have a Keras model, you can use the TensorFlow model optimization toolkits to optimize it to put it on a mobile device, and you can use TF-Lite and so on. And like, if we just start writing Keras models in JAX, you actually lose all of this. So another thing we could do is more like trying to build kind of bridges between JAX and Keras. Like, what if we kept all of the existing TensorFlow Keras stuff, but we also enabled you to start writing Keras layers in JAX, but then you can still use them in a TensorFlow-centric workflow, right? Because ultimately they compile to XLA, right? So they're actually compatible with TensorFlow. So that's an option I'm currently looking at. Like, what if you could just drop JAX code into a Keras layer or a Keras loss function, maybe a Keras train step, and that would just work. So that's another option. And a third option is like just trying to re-implement the Keras API from scratch in a very simple way on top of JAX. And that would be like a fresh start. It wouldn't really be like fully compatible with the old Keras because the old Keras has all these features which are TensorFlow specific. And that would actually be relatively easy to do, with the downside that it may lead to fragmentation, right? Because then you start having two slightly different versions of the Keras API. And also the downside that, like the Keras is really an object-oriented framework, and JAX is functional. And so this is like very different philosophies. So if you implement Keras on top of JAX, you still end up with an object-oriented framework, right? You can lose, by design, you're going to lose the functional aspect. So, and at that point, you might as well be writing your layers using the TensorFlow NumPy API, and it would look almost exactly the same, and compile them to XLA, right? And then it would look almost exactly the same as the JAX workflow. So again, like this is a super interesting problem, and I would really appreciate like community feedback on what do you want us to do? What would be your use case? Why would you want to use Keras and JAX? Because once we understand that, we can make better decisions.
Thanks for that answer. The next question is by Akash Nan, who is, to me, one of the Keras heroes. He's contributed a lot to the community. If you were to rewrite Keras today from scratch, what would you do?
Right. I mean, this is something we've actually kind of looked at in practice in the context of JAX. And there are actually lots of things we can change or simplify. Things that were kind of design choices that were constrained by the original Theano and then TensorFlow backends, right? And there's like a pretty long list of them actually. So you'd end up with a code base that would be significantly smaller and simpler, and that would be a good thing. But at the same time, if you were, for instance, to write it from scratch into JAX, you would not really end up with something fully compatible or something fully feature complete. And so a lot of the existing behaviors of Keras are actually there for backwards compatibility reason. And that's a feature. Like I think so Keras is very much this infrastructure layer that other people build on top of. And stability is a super important property of an infrastructure layer. Like you don't want to make changes that end up simplifying the code base, but that also break existing code that's relying on your framework, right? So that's something that happened, for instance, in the transition from TensorFlow 1 to TensorFlow 2. And I disagree with that personally. Like I think that's bad. I think you should aim for as much stability as possible. And if you want to break things, that's okay, but you should do so in a very careful and incremental fashion, right? We should not basically invalidate people's code bases out there, because that's like millions of hours of engineering time, and that's precious, right? You should take care of it.
Thanks. I know we're almost out of time, but is it okay if I squeeze in another question?
Yeah, absolutely.
So this is by Ido Ben. I'm sorry if I mispronounce your name. What are the most interesting theoretical directions in ML or DL research, according to you, in the horizon?
So, I mean, there's a lot of really interesting stuff going on. So one topic I'm really passionate about is, in general, discrete reasoning and figuring out how to leverage. So deep learning models, they're very much curves, so they're very good at doing things like intuition, perception, interpolation type of information processing. And discrete reasoning is kind of like at the other end of the spectrum. But I think we can really kind of like bridge both worlds and create systems that will leverage the strength of each side, like the strength of deep learning models, the strength of more discrete systems, like for instance, program synthesis algorithms. Like how you can use deep learning to guide a program synthesis system, how you can use program synthesis to enhance deep learning architectures and so on. So that's an area that I'm really passionate about. There are many other things. So another, there's lots of things we can do in general to address the weaknesses of deep learning models. Like for instance, deep learning is not really able to do out of distribution generalization, right? Well, that's also an area where there's lots of interesting work that's currently going on. And this is actually something we can probably do without involving too much discrete reasoning, just by staying in the deep learning framework.
I think in your interview on MLST podcast, which is an awesome podcast, and also with the Lex Fridman podcast, you went into depth in these topics. I would encourage the audience to check those out. Awesome. We're over time. So I'll quickly mention to our audience, please connect with Francois on Twitter. He is FCHOLLET on Twitter. On there, you can find the link to his book that we'll be reading and also his website where you'll find all of his links. Francois, any final words to the audience that will be going through your book over the next few weeks?
Yeah, I just want to say, thanks for having me on the call. It's been great answering questions from everyone. And yeah, and please enjoy the book. Like it's not just meant to be a book that gives you some specific piece of specialized knowledge. It's also meant to be a fun read. So I hope it will be fun.
Thank you so much, and thank you so much again for your time. It's an honor to kick off the reading series with you.
My pleasure. Thank you.